Welcome to a short tutorial on NewEagle's Raptor Dev. What we're going to have a look at first is the template that is created alongside every display module. As you can see here, I'm using MATLAB 2014B and Raptor 2015A002. So first, we want to create the project. So we're going to type in Raptor create display project. You can press the tab key to use the autocomplete function. I'm going to name this one example using single quotes, and now press enter to build your model. Now that the model is opening, you will see some Raptor blocks. These Raptor blocks are very useful to help your model set up from the start. We want to navigate to foreground, which is the gray block, so double click on that, head into here, and this displays is where we want to go. And then the green one is screens. We're going to take a look at screens first. As you can see, there's a full screen, quad screen, and splash screen. The full screen right here is the first screen, and then the quad screens are the second screen. So you take a look in full screen and you'll see two blocks, the gear indicator and the draw fault icon, but there's no point looking at blocks when we can actually look at the model itself. Press Ctrl B to build your model, and this is exactly what you get straight out of the box with Raptor Dev, and it is fully functional. I'm going to pause the video while I build. Now that the model is built, we have our PC simulator of the VCAN 320. Here we see the main screen with the fault simulator icon in the top right left hand corner, and if we use the first button to navigate to the second screen, this is our quad screen. We have 3 gauges that can be hooked up over CAN to any network you prefer. There's a fault simulator in the top right hand corner, and that is also a simulated demo sensor, much as the first screen is at the moment, but those can also be changed to be connected with over CAN. Now that we have our template working, I'm going to create a new project with the same template to show you how to modify it and what you can do with it, all within a short amount of time. So feel free to continue to use the model that we just created with your Raptor demo template. Alright, open up your Raptor demo template, but we're going to actually navigate to the MATLAB's library directory. So click right there, and you're going to want to drag in the demo library SLX from the Raptor demo package.zip that NewEagle has provided, and we're going to use this library for development in the model. Alright, so now what we want to do is navigate to screens. You go foreground, display, screens, and now we're here. So first thing we're going to look at is this full screen. That's actually a Raptor block. So now we're going to open up full screen, and notice there's lots of options what we can customize this Raptor gauge for. Make sure you set the maximum value to 200, and then you can change whatever you like on this. I'm going to change the marker numbers so I can have 2 and 4, and we're going to have the background markers be gray and the needle be red. Now we're going to head over to the update function of the full screen. Head in there, and we're going to delete the green one, which is the fault draw icon block. So we're going to get rid of that. It's just going to get in the way for what we need. Here we have 2 places that handle buttons: the create background and the button handler. The button handler basically dictates what the button does, so if you press button 2 in this case, it's going to use the Raptor go to block to go to the quad screen. Now we're going to change what our buttons look like, so head over to the create background function, and now we're going to go to our MATLAB images directory because we need some custom images for our buttons. So here's our images directory within our Raptor Dev demo package. So navigate there and copy and paste all the images in. Just like that. There we go. And now what we're going to do is head back to the model, and what we need to do is insert a Raptor reference image block. So head over to the MATLAB Simulink directory, type in image, and it should be the first one there. It is the second one, and drag that in. Right click to drag because we're going to need 2 of them, and what we're going to do here is open it up, and we're going to need a not pressed and a pressed image. The first one we're going to have a gray not pressed square, the blank one at the top, the third one in, and then for the second one we're going to do the same thing but get the yellow one, so it looks like when you press it, it turns from gray to yellow. Now we need to open up all the buttons that we're not going to use, such as button 1, 3, 4, and 5, and we need to set those to images from ports. So check that box, and we need to drag the gray one to all the top not pressed ports, and then we need to drag the bottom one, which will be the yellow button, to the pressed ports. So I'm going to pause the video as I connect all these up. Now they're all connected up, what we want to do is set the second button's images. So we're going to open that up, press select image, and notice you're in the default Raptor library. We need to head over to our MATLAB images directory, so navigate there, and I recommend you copy and paste the link in because we need to do this twice. For the pressed image we need the yellow right arrow, and then for the not pressed image we need the gray right arrow. Alright, so I've navigated back to screens for the next part. So this part we're going to set up the quad screen. So as you see, there's some demo sensors enabled with the quad screen. So first of all, we're going to just delete those, because we're going to come back to sensors later and hook all those up and get those going. So this is a Raptor block, and this is a quad screen as it's called, and what we want to do first is make sure the top two gauges are disabled, because we don't want anything on the top half of our screen. We just want the two lower gauges enabled for what we're going to do. So those two are disabled, and now what we're going to do is for this one we want to have the values be correct. So for our project we need 0 to 150, and then we're going to go down to the image. So press select image, and that's going to pop up the default Raptor library, which is what we want in this case. So find the fuel temperature. You guessed it, this gauge is going to be the fuel temperature. And then the second one, what we want to do is have 0 to 100. And I'm sure you can guess what 0 to 100 is now. It's definitely going to be the fuel level. So go down to the fuel level icon, which is, there it is, and press OK. Actually, before you press that, you want to change the needle color. So select, we're going to use yellow. You can use whatever color you like. There's bunch of colors to choose from, so press select color and then pick whatever color you'd like. Alright, so now we're going to navigate to the update function of the quad screen. So double click right there, and you see all this content in here. It's actually in our way, so we're going to select all of it and delete it. Keep the trigger at the top, we're going to need that though. We're going to head into the Simulink library browser. We're going to type in if. So we're going to scroll down to if, and we're gonna pull in the if block, so it should be down here. There it is. So we're gonna drag that in, and what we need now, if you were gonna do this by hand, you would get a if action subsystem block, and I'll show you this. It is right here. We're gonna drag that in, and if you're gonna do this by hand, you'd put all your content in there and you'd be good to go. But for the demo, we have provided the subsystem for you. So if you want to head over to the Raptor demo library, we're going to drag in the disabled in this case, which is the red one on the left. Bring that one in, and you're going to connect that up to the else of the if block, as so. And then what you want to do is you want to get the input for the if block, which is a Raptor block. So you type in data, and then you scroll down, and you should see a bunch of Raptor blocks. There they are. You're going to want a data definition, which is that one, and you want a data read, which is that one. So we're going to bring in the data read, and then we're going to bring in the data definition. The data definition can go anywhere, so we'll just have it here for just so we can see it and edit it. And then we want to have a name for both of those. So let's use status. You're going to need to have single quotes around the name for it to work. So that's the data read, and then the data definition, we're going to have the same name. So, and then the initial value is 0. That's what it's going to output by default unless it is changed. Here we're going to go into the if, and we want it to be if it's equal to 0. So set the two equal signs there, and if it's equal to 0, we want it to be disabled. So 1 is enabled and 0 is disabled, so actually connect the disabled to the output of the if. So here we go, we're going to copy the disabled over, and we're going to make that an enabled block instead. So what I've done here is accidentally made the foreground green. Really we want the background green, so change the background to green. There we go. Alright, so enabled green, disabled red. Alright, so in this enable block, as you can see, everything is orange, and same as the disabled, because they're copied. So we want everything in the enabled to be green. So head back over to the enabled, and if you look in the image directory, that we dragged in, there should be a green counterpart to the orange gradient. So we're going to select that, and we're going to change the name from status disabled to status enabled, and then we're going to change the color to green. You don't have to have it green, you can have any other color you want, but for this enabled screen we're going to demo green. I have green there and there, so that is the enabled color setup, so it's that easy to just change the colors around. And then now what we're going to do is make this work. Since we deleted the sensors, that line is no longer connected, you can delete that. And we're going to go to the button handler now. Now in the button handler, what we want to do is make sure we have 3 buttons. So we have buttons 1, 4, and 5. So we're going to open them up and make sure it has 1 for the first one, and then 4 and 5 for the second 2. For the first one's going to go backwards to the main screen, and then buttons 4 is going to enable the status screen, and then button 5 is going to disable the status screen. The button handler is an essential part of any display because it lets you navigate between your screens with ease. So I renamed them enabled and disabled just for ease, for when we come back we can find them quickly. And also gonna recolor them. That's a nice feature. You can have them red and green for corresponding colors. What we're gonna do here is go into the 4th one to create the button handler for this one. Here in enabled we want a constant and a data write block. So the constant is 1, so whenever you press this button it's gonna data write to the status screen a 1, and then if you remember we have 0 and 1 on that if block, and 1 is enabled and 0 is disabled, so that 1 is now going to be transmitted to the status data. That's going to make our screen enabled for us. And then this one is going to be set to 0, and that's going to disable it for us. So that is all set up there. Now we're going to head over to the create background and change the images of the quad screen buttons. For button 1, we want a left arrow because we're going backwards to the first screen, so we need the gray one and the yellow one for not pressed and pressed. Make sure you navigate to that MATLAB images directory. I'd recommend you copy and paste that link, it's a lot easier to get to that way. And now over in the second button, we're not actually using the second button, so that's okay, we can just set it to a blank gray and a blank pressed for the yellow. For the third button, we're not going to actually use that button. We're going to use those blank buttons we used in the other screen, the gray blank and the yellow blank. We can navigate to those directories, paste that link, get the gray one, do the same for the yellow one, paste that in and get the yellow one. So what we want to do now is go to the 4th button. So for the 4th button, we're going to use the check mark for enabled, so there should be a gray check mark right there, and then also a green one. When we press it, it's going to show up green, and then it'll enable the screen. For the 5th one, we have an X, so open that up, paste the link, and get the X. Now we have all our images in the button handler for that quad screen. We're done with it, and we can head back up to screens to do something else. So if we went to build this right now, we would run into a little error of a unit conversion. So you can change the type on the block, or you can actually go into the library and bring a conversion block in. So if you just type in conversion and drag that conversion block, put that there, that'll convert it for you. Or you can change it in the constant itself, but for now we just use the data conversion block. So for the last part, we're going to navigate back to foreground, and we're going to click on plant and then sensors. We want to delete everything I delete, so demo sensors, the top Raptor block, the merge block, and that line into virtual sensors. And now connect your sensors up there and open up virtual sensors, delete all of these, everything except the time block and those 2 blocks in the top right hand corner. Set your bus to 2, and you can make it look pretty if you'd like. And now navigate back up to sensors, open sensors, delete that enable, and then open can. Delete the top 2 cans and the last one, set the bus to 1, or completely get rid of the bus, and then connect your can up to the signal. So here what we're going to do is set up the can communication. So we're going to open that up, and here is your standard can message block. This is what it should look like. Now what we need in here is an enable. So we're going to take the enable, and it is right there, sixth one down. Pull that out there, put that on the top, and we'll use that later. We're going to disconnect all these CAN messages just to have a clean start once we load the new DBC file, which is going to come from the Raptor demo package that has been provided. So you want to navigate to your Raptor demo package folder and drag in the demo_can.dbc into your CAN MATLAB directory, and that's what we're going to use for CAN communications in this project. So now open it up and load the new CAN file as such using the Raptor CAN GUI. So we have fuel, speed, and temperature. Now you want to make the bus 4 instead of 5, and then connect up all 4: age, fuel, speed, and temp. You can do a control click that does all 4 at once. And now head back over to sensors, and what we want to do in this CAN block is make the enable and disable status work. So we use that by using a data read from one of the Raptor blocks. We put that there and then name it status as we have ours named, and basically we want, when it is 1 we want it to be enabled, and when it is 0 we want it to be disabled. So that needs to be 1 for this to work. So we're going to set a compare to constant, and we're going to have equals equals 1. So it will only be enabled when it is 1. Now what we're going to do is head back over to screens and connect up the main screen and the quad screen. We'll start with a quad screen, and what we need is a bus. So specifically a bus selector. We're going to want to connect it up to the lower left and lower right gauges. So we're going to port the temperature to the lower left and the fuel to the lower right, because those are what our gauges are for. And now we need a ground. So the ground is going to go for the top 2 just to clean up those. We're not using those, so we're just going to ground those ports. Now we're going to set up the CAN signals for the main screen. So what we want to do is get a bus selector and put that in front of the full screen, and then hook up the sensors to the back of that. We need to select the CAN sensor of speed and then connect that further to the full screen. Connect the main sensor line to the update function of the full screen, and then we're going to go inside of the full screen update function and port that. Make sure it's on the bus for the gear indicator. So the gear indicator was going to have 2 incorrect CAN signals. We need to delete those and put our own speed and our own age into those as such. Now actually go into the gear indicator subsystem, and then furthermore into the bottom right subsystem. In there we're going to change and look at 4 of these compare to constants. The middle 2 are going to stay the same. The top one is going to be equal to 0, which will stay the same, except the very last one needs to be greater than 0. What this does is ensures that our gear indicator is in drive when the speed is increasing or anything other than 0. Alright, I believe we are ready to build. You can press Ctrl B to build, and if you're using this version of MATLAB, you can press View Diagnostics to watch it build, or if you're in an older version, you can go to the MATLAB command window and all your information will be there. Your PC simulator will build shortly, and we'll take a look at that when it's done. Alright, here's the PC simulator, all built from our model. We're gonna take a look through the screens here, and as you can see we have our status disabled at the top, and we can enable it using the 4th button. There we go, and switch back and forth. So what we're gonna do now is we're gonna make sure the CAN works. We're gonna open up Raptor CAN, another New Eagle Raptor tool, and this one lets us, among other things, to monitor and simulate CAN traffic. So we're gonna go over here, we're gonna click on simulate, we're gonna add our demo DBC file. So here are demo CAN right there. You're gonna click on that, bring that in, and what we need to do is if we expand it, we'll see fuel, speed, and temperature that we've been using throughout the project. Make sure our status is enabled, because that we have a check that disables the CAN traffic, and turn it on and start dragging your speed, and you should see your main dial moving up and down. We only have 5 markers, so we can increase that up to as many as we want so we can have a more refined image. Here we have fuel and temperature going up on the second screen. They're functioning correctly. Thank you for watching this short tutorial on NewEagle's Raptor Dev. As always, for more information, please visit www.neweagle.net.